Hi, today we'll talk about recursion. So the definition of recursion is a function calling itself is called as recursion. So here is an example of a recursive function. So this function is basically to calculate the factorial of a number. So inside this function, if you see this statement, this statement is a call to the same function with parameter n minus 1. So let's execute this function on some example number. Let's say this is the call to this function, fact of 5. So let's number the statements here. This is statement number 1, let's say statement number 2, statement number, this is 3, right? So when we have this call fact of 5, this function starts executing. So statement number 1 is checked. So for this call n is equal to 5, n equal to 5. So statement number 1, we check whether n is equal to 1. This is not equal to 1, so we don't execute statement number 2 because the condition in statement number 1 is false. So we go to statement number 3 and execute it and say return n is 5 into fact of 5 minus 1 is 4, right? So before closing this bracket, we have to complete this call. So I go to execute fact of 4. That means I execute the same function factorial, but this time with n equal to 4. So I execute statement number 1, but find the condition in statement number 1 is false because n is not equal to 1, n is equal to 4. So I go to statement number, I don't execute statement number 2, I directly go to statement number 3. And statement number 3 is itself a call to the fact function. So n is equal to 4 here. So 4 into fact of 3. So I go to execute this call fact of 3. So here is fact of 3. Execute the same function fact with n equal to 3 this time. So because we passed 3. So I check the condition in statement number 1. The condition in statement number 1 is false because n is not equal to 1. So I don't execute statement number 2. I go to statement number 3. So in statement number 3, I have written n into n fact of n minus 1. So here n equal to 3. 3 into fact of 2. So I have a call again. So I go to execute fact function. So again I execute fact function, fact of 2. So I execute statement number 1, but the condition is false, so I don't execute statement number 2. So I go to statement number 3 and say return n equal to 2 here. So 2 into fact of 1. So I have this call to fact of 1. So I execute again the fact function. So fact of 1. So here n equal to 1. This time I execute statement number 1 and find n equal to 1. So the condition is true and I return 1 from here, right? So first time I am returning some value. So I return this value to the function which called this function. So in fact this fact of 1 will get replaced with 1, and now I can return 2 into 1 is 2 from this, right? So I am returning 2 from here now. So I'll return 2 from here, so I'm returning 2. So this 2 will replace this fact of 2 call. So now from here 3 into 2 is 6, so I'll return 6 from here. So this 6 will replace this fact of 3 call. So 6 into 4 is 24, so I'll return 24 from here to the function factor 5. So 24 I'm returning from here, so 24 will replace this. So now 5 into 24 is 120, and so from here I'll return 120 as answer to fact of 5 call. So this is how recursion works. So just to summarize what we saw, I have used a formula here, factorial of a number n is equal to n factorial is equal to n into n minus 1 factorial. So this is the formula which we have used here. So I know factorial of 1 is 1, so that means if I am asked to calculate or compute the factorial of 1, so I'll directly return 1, otherwise I'll use this formula. So n into factorial of n minus 1. So I don't know factorial of n minus 1, so I will use the same function to calculate the factorial of n minus 1. Right? That's why I have called here fact of n minus 1. In fact, so the working is like this: 4 factorial is equal to 4 into fact of 3. So fact of 3 is nothing but 3 into fact of 2. So fact of 2 is nothing but 2 into fact of 1, and this is 1. So then from here we'll return 2. 3 into 2 is 6. So 4 into 6 is 24 will return from here. So thanks for watching.